So these are the topics we'll be covering in a set of videos. Now in first video, that is this video, we'll be covering introduction to general sequence, that is the first pointer, then arithmetic progression and geometric progression. Okay, so let us start. Okay students, so the first one is sequence. Now sequence is a set of numbers. Sequence is a set of numbers having a definite relation between numbers and their positions. Okay students, so let us try out some sequences. For example, if you see example, 2 4 6 dot dot dot, this is a sequence because it is a set of numbers where you can actually predict the next term by looking at the relation between previous terms. Yeah, so as we are adding 2, the next term is going to be 8 here, so this is a sequence. This is perfectly valid sequence. Now if you look at another 10 9 8 7 dot dot dot, is this a sequence? Yes it is, because you can predict the next term as 6. Yeah, so you can say students, sequence can be a set of numbers where we can predict the next term. Alright, now for a sequence guys, if you take the first term, it is denoted by T1. For any sequence, these are the notations: T2, T3, T4 and so on. Okay, so this is how we denote a sequence. Alright, now let us see some special results. Okay, so these are some of the terminologies that we'll have to remember. T1 is the first term, as you can see here, and it is also denoted by A. Sn is sum of n terms, where n can be any number. T2 is S2 minus S1, right? T3 is S3 minus S2, that is sum of 3 numbers minus sum of 2 numbers. Okay, and similarly you may write Tn. Any term, any in between term can be obtained as sum of all terms up to n minus sum of n minus 1 terms. Okay students, so after sequence we'll see types of sequence now. The first type of sequence is arithmetic progression. Okay, so how do we define an AP? AP is defined, this arithmetic progression, which also is called as AP, it is defined as a sequence where difference between any two terms, any two consecutive terms, is always constant. And remember guys, difference is taken as second term minus first term, third term minus second term. So in general it is written as Tn plus 1 minus Tn equals constant. So you may assume this as a definition for an AP. Let us see general form of an AP. So students, in AP is written as A, that is first term, A plus D, A plus 2D, A plus 3D and so on. Now from this general form guys, we can make the general term, that is Tn is given by Tn is equal to A plus n minus 1 into D. Okay, so this is another expression that we need to memorize while solving the problems. Okay, now how this arrived students, let us see that first. T1 is first term, so T1 is A. Look at the second term, this is T2. Let me write this as T1, this is T2, this is T3, this is T4 and so on. So guys, T2 is A plus D. Can we say it is A plus 1D? Yeah. T3 is A plus 2D. T4 is A plus 3D. And T5, if you see, it is A plus 4D. That means if there is 4, I am having 3 before D. If it is T5, we may have A plus 4D. T6 A plus 5D, T10 A plus 9D, T20 A plus 19D, and hence Tn is A plus n minus 1 into D. Sn, that is sum of n terms, is given by n by 2 in bracket 2a plus n minus 1 times d. Okay, so here n is number of terms, a is the first term, and d is the common difference. At times, to find sum of n terms, we may also use Sn is n upon 2 in bracket a plus l. Now what is this expression, guys? I'll tell you further. It is n upon 2 into first term plus last term. Now what do we mean by assumption of terms? Suppose a sum says 3 terms are in AP. So 3 terms in AP given in a problem, you can assume them as a minus d, a plus d. Okay, so that the calculation part becomes easier. If they say 4 terms are in AP, then we may assume them as a minus 3d, a minus d, a plus d, and a plus 3d. If 5 terms in AP, then we may assume them as a minus 2d, a minus d, a plus d, and a plus 2d. So guys, what does this mean? If you pick up any AP, 2, 4, 6, 8, 10 and so on, and if you add any number, let us say plus 1, then if you add a plus 1 here, then the sequence will become 3, 5, 7, 9, 11, but it still remains an AP. So this is what this property says. Similarly, so guys, if you multiply and divide by a number to each term, the resulting sequence remains AP. So this is, you should remember for an AP before solving any problem. Now, if we see a sequence, let us say 2, 4, 6, 8 and so on, you may say, sir, there is a difference which is constant, that is 4 minus 2 is 2, 6 minus 4 is 2, 8 minus 6 is 2. So here the difference between any two consecutive terms is constant. Yeah. Now if you look at the another sequence, that is 2, 4, 8, 16 and so on, do you see the difference constant here? Difference is 2, 4, no, it is not constant. Then how to predict the next term? Can you predict the next term in second sequence? 2, 4, 8, 16, then next would be 32, right? But how did we get that? How our brain calculated it? Because the ratio of 4 and 2, 8 and 4, 16 and 8 is always constant. The ratio was 2. Okay, so here ratio between any two consecutive terms is constant, and this kind of sequence is called as a GP, whereas the first one we just saw, it was called as AP. So let us define GP now, students. GP is defined as a sequence where Tn plus 1 divided by Tn is always constant. So geometric progression is defined something like this, where ratio between any two consecutive terms remains same. Okay guys, and here as the ratio is common, it is denoted by R. They call it common ratio. Now students, the first term is always taken as A. Now you know it. Now the second term is taken as AR. Why AR? Because we need ratio to be R. Ratio should be constant. Third term is taken as AR square. If you divide AR square by AR, again you get common ratio R. Fourth term is AR cube and so on. So this is called a general form of a GP. General term is denoted by Tn and it is given by A into R raised to n minus 1. Now how to remember this? So if you look at the first term, it is A. Second term AR, it is A into R raised to 1. Third term is AR square. Fourth term is AR cube. Remember this is T4 students, okay? So 4 is having 3 here. T3 was having 2 as power of R. T5 would be A into R raised to 4. T10 would be A into R raised to 9. And hence Tn is A into R raised to, reduce it by 1, n minus 1. After general term, we'll see sum of terms. This is the formula we can use to find sum of n terms of a GP based on given values of R. So common ratio is not plus or minus 1. Any other ratio, you use the first one. If common ratio is equal to 1, use the second. Common ratio minus 1, use the third. Okay, students? So how to find sum of infinite terms of a GP? Let me tell you first, S infinity will exist only when mod of R is less than 1. Okay, so this common ratio must lie between minus 1 and plus 1. Okay, and if you get such an AP, then you can actually find sum of infinite terms of that GP, and S infinity is given by A upon 1 minus R, that is first term upon 1 minus common ratio. So this expression is quite important when a question says find sum of infinite terms for a geometric progression. Three terms are in GP. So if you want to assume three terms in GP, let me tell you two options. You may assume them as AR square, or still simplified version, you may assume them as A by R, AR. Okay, if four terms are in GP, if a question starts like this, four terms are in geometric progression, then we may assume them as AR square, AR cube, or A by R cube, A by R, AR, and AR cube. So you may take four terms as this or the first set. Okay, and similarly, if five terms are in GP, then we may assume them as AR square, AR cube, AR raised to 4, just go on increasing the power, or A by R square, A by R, AR square. So it is up to you students which method to use. You may use any set of numbers when a question says particular terms are in GP. Okay, so if you want to keep GP same, or you want to keep GP as GP only, we may multiply each number or divide each term by a non-zero number, or we may raise each term to any part. Okay, so this is all you need to know about GP, and here we end the first module. Thank you.